So, get out your Chapter 3 review quiz, please. I'll pause for a few seconds while you're all finding it. So if you combine the 3 quizzes that I've given you, the Chapter 1 naming, the Quiz 1 on naming, Quiz 2 on more naming and crisscross and ionic and polyatomic, and even drawing a couple of Bohr diagrams, and this one here, which has a little bit of everything, including physical and chemical changes, you're in pretty good shape for the test next class. Again, if you are away Thursday, please try to track down my TOC for Friday. It's well worth writing the test before Christmas. Waiting till after Christmas, I guarantee you won't do better. You'll forget it all. So, I've stalled long enough. Here we go. You all know what's coming. My favorite student. Good old Ann Serkey gets everything right. Which of the following is an ionic compound? Now, the way I can tell that it's an ionic compound is it's going to be a metal followed by a non-metal or a polyatomic. So, no. Phosphorus is a non-metal. Phosphorus is a non-metal. You know what? Has to be D. Has to be D. Wait a minute, Mr. Dueck, you said a non... Yeah, polyatomic is a non-metal. That's a ionic compound. The other, these two are covalent. This one is not even really a compound. It's a single element. Speaking of compound, which of the following is a compound? Now, a compound is a 2 or more elements that are combined, and I should add one more thing, combined without a charge. This is an ion, it has a charge. This is an ion, it has a charge. This is only a single element. Nope, 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 yep. The correct answer is A, 2 only. Consider the following formula, Na2CO3. What's the ratio of positive to negative ions? Well, the positive ion is sodium. The negative ion, and it's a polyatomic ion, is CO3, which we've called, what is CO3? I gotta go look it up on my periodic table. Carbonate. What's the ratio of positive to negative ions? We have 2 sodiums and 1 carbonate. Wait a minute, Mr. Dueck. There's 3, there's 3 oxygens to combine with 1 carbon to make up 1 carbonate. The answer is B, it's 2 to 1. What's the formula for aluminum hydroxide? Aluminum from my periodic table is Al3+. Hydroxide, that's a polyatomic ion. That is this OH negative right there, this puppy here. Now, when I use that lovely little crisscross trick, there's going to be a 1 there and a 3 there. It's going to be 1 aluminum, 3 OHs. Now, this is saying only 3 H's. This is not, that 3 there is not on the OH. You know what? I got to put the polyatomic, oh, Mr. Dueck, let's go back to red to be consistent. D, that is aluminum hydroxide. You'll need 3 hydroxide polyatomic ions for every atom of aluminum. Which of the following terms correctly describes CH3COO negative? Now, I recognize this actually. This is acetate. Which is an ion. In fact, it's a polyatomic ion. It is not multivalent. It doesn't have more than 1 ion charge, and it's not a compound. So, 1 and 3, D. What's the name of the metal ion in Fe2S3? Oh, wait a minute. Iron, I bet you that's a multivalent. Yep. That's what I thought, multivalent. So how am I going to figure this out? I'm going to look at the non-metal, which I think was sulfur, wasn't it? Sulfur. Each sulfur is -2, and there are 3 of them. That means in terms of negative charges, I have a total of 6 negative. That means in terms of positive charges, I have to have a total of 6 plus. Now, how many irons do I have? 2. I have to have a total of 6 plus. I only have 2 irons. That means each one of them has to be worth 3 plus. This is going to be iron 3 sulfide. What's the name of Na2CO3? Na, please tell me it's, not multivalent. Thank goodness. So it's going to be sodium. Does that help? Oh, you know what? Doesn't help. Oh, CO3. That's a polyatomic. In fact, I think that's carbonate. Yes, it is. Carbonate. It's going to be sodium carbonate. A. What's the name of S2 PB? Oh, lead. Oh, wait a minute. Lead. Ding, 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 ding. Lead. Yeah, I think that's a multivalent. So it's either going to be lead 2 or lead 4, or there are other possibilities, but let's see. Sulfur. If we look at the sulfur, there's 2 of them. Each one is worth what? What's the charge on a sulfur ion? When I look up sulfur's ion charge, it's 2 negative, so the total negative charge is 4 negative. That means the total positive charge from that lead has to be 4 positive. How many leads are there? Just 1. So that lead, oh, let me do it. There's lead. How many leads are there? Just 1. So that lead, since it's only 1, has to cancel out these 4 negatives. It has to be a 4 plus on its own. It's lead IV, lead 4 sulfide. By the way, I would have crossed out this one. I should have, because sulfate is the polyatomic. Sulfate is this puppy here, SO4, and there's no SO4 in this one. How many atoms in total are represented by the formula? Wow. Well, let's see. There's a 1 right there. So how many N's? 3 of them. You know what? In fact, if we're clever, why don't we do the brackets first? There's a total of 5 in the brackets. 4 hydrogens, 1 nitrogen, times 3. There's 15 in the front one, plus... Is there a number out here? No. What about this 4? Is it on the P? It would only be on the P if it was in brackets like that. It's not, so that 4 is only acting on the oxygen, not on the phosphorus. There's 1 phosphorus, 4 oxygens. There is a total of 20, wow, atoms in that 1 compound. By the way, I think that would be ammonium, PO4, phosphate. An explosive device is used to blast rock for the construction of a new highway. Which set of terms describes the explosive device? Well, let's do the first half. You know what? It's not... Oh, sorry, reading this wrong. Give me 1 second. I got to pause the video. Someone just knocked on the door. Oop. Let's try that again. Okay, sorry, we're back. Let's get the easy one first. Explosives, do they give off heat? Yeah, so it's going to be exothermic, not endothermic. So I'm going to say no, no. So it's either a physical change or a chemical change. Well, an explosive is actually, when you have an explosive device, chemical bonds are being broken, new things are being formed. It's not reversible, so it's a chemical change. All right, little matching here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So 2 of these won't get used. An ionic lattice. I think maybe a highly ordered array of ions. No, 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 no. Yeah, you know what? I'm going to go with B, and I'll cross it off because it says it's only going to be used once. Reactant. How about the material that is made during a chemical reaction? No, and that's wrong. That's the product. The starting material, what you're reacting, H. Good gosh, Mr. Dueck. A molecule refers to a metal, no. Non-metal, no. No. Oh, you know what? Non-metal that has I'm not sure what they're getting at. Let's come back to that. Ionic compound refers to a metal and a non-metal chemically bonded. I think so. Let's see. Non-metal that has a no. Ion made of several atoms. Well, you know what? D, that's a polyatomic ion. I can fill that one in right there. May form a positive. Oh, you know what? And E, multivalent metal. If they just said multivalent, well, all metals, non-metals are not multivalent. So multivalent metal may form a positive ion in more than one way. Material that is made during a chemical reaction, maybe that's a molecule. A group of atoms joined by covalent bonds is a molecule. Okay, let me just see what we're getting at here. I'm going to actually have to pause and check my answer key. Good gosh. Yeah, I should have figured this out. Sorry. And I don't know if I've done a great job of explaining this, but a molecule is going to be F, a group of atoms joined by covalent bonds. That's the difference between an ionic lattice, where they're joined by ionic bonds of attraction, but they're not held firmly in place the way a molecule covalently is. Oh, and an ionic compound, that refers to a metal and a non-metal chemically bonded. A. Oh, I should have crossed that one off. By the way, material that is made, we call that the products, for what it's worth. Short answer questions. Okay. How is this like a molecule? PO4 3 negative. Well, it's like a molecule because there's more than one atom, and it's covalently bonded. How is it like an ion? Has a charge of 3 negative. Write the formula, 1 mark each. Magnesium nitride, that's going to be combining magnesium and nitrogen. Magnesium is 2 plus, nitrogen is 3 minus. That's going to be Mg, 3 of them, N, 2 of them. Nickel 3 fluoride, that's going to be nickel. Now nickel is multivalent, but it tells me it wants to use 3 plus. Fluoride, thankfully, is not multivalent. You know what? It's going to be Ni, 1 of them. I'm not going to bother writing the 1. F, 3 of them. NiF3. Ammonium sulfate, not sulfide, sulfate. Okay, these are both polyatomic ions. I got to go look here. Where's ammonium? NH4 plus. And sulfate, SO4 2 negative. And you know, when we crisscross, we'll probably end up putting these in brackets. There's going to be 2 there, 1 there. It's going to be bracket NH4, 2 of them. SO4, 1 of them, but you know what? I don't need to put the 1, so I don't need to put brackets. You can, but you could put a bracket there, and then say there's 1 of them. Write the name, SR. Now, SR is strontium. Hey, not multivalent, so it's going to be the IDE rule. It's going to be strontium phosphide. V2, V is vanadium. Vanadium is multivalent. So it's going to be vanadium something. Okay, let's see. Oxygen has a charge of 2 negative, and there's 5 of them. So I have a total of 10 negative charges. So I better have a total of 10 positive charges. Now, how many vanadiums are there? There's 2. So I guess vanadium, which is here, vanadium, no, that's W. Where is vanadium? Right there. You know, oh, good. It can be that. I just wanted to double check. It's going to have to be a charge of 5. It's going to be vanadium 5 oxide. Hey, Mr. Dueck, the element whose symbol is V has a charge of V. Wow. Wow. That is so profound. Wow. Wow. Moving on. CS2 CR2O7. Okay, CR2O7, that's from the back here. CR2, that's dichromate. It's 2 negative. How many CR2? Just one of them. CS, not multivalent, so I don't need to bring out the Roman numerals. It's going to be, is it CAE? CE, never mind. Cesium dichromate. Let me spell that one right. Dichromate. What's the difference between a chemical change and a physical change? In a chemical change, something new is produced. That's terrible. Physical change. Nothing new is produced. There's one way. What else could you say? You know what? Let's cheat and look at my answer key here. Chemical change, new substances with new properties are produced. Well, in the physical change, no new substances are produced. Well, okay, that's exactly what I said. 1 mark for each of those. If you can, when 1 mark for each of these, probably what I would do is I would give you a half mark if you had this name right, a half mark for that, half mark for this, half mark for that, but I'd take a half mark off if you missed the Roman numeral 4, half mark for that, half mark for that. Here, half mark, but you also have to have the subscripts correct. Half mark, but you also have to have the subscripts correct. Half mark, got to have the subscripts correct. 1 mark for each of those. Give yourself a score, please, out of 26, but I'm not going to collect this quiz. I want you to hang on to it to study from. So your score is only for your own personal self-edification. All right. So that's the quiz. Your test is next class. You have the remainder of class to do corrections, to work on this. If you want something to study, I'll show you what you can work on. Just give me 1 second. Let me hit save. I'll pause the video first. So if you want more practice, there is a review for the chapter. It's in your textbook. It's on page 106. Questions that I like. Under checking concepts, sure, number 1. Number 2, you should know the difference between ionic and covalent. Oh, that's the answer to 2A. I'm not going to ask you to draw a covalent molecule, so don't worry about number 3. Why is this molecule? Don't worry about number 4. I'm looking here. Questions that I like. Certainly number 8, you should be able to tell whether whether things are covalent or ionic. Again, if it's got a metal plus a nonmetal, it's ionic. If it's 2 nonmetals, it's covalent. That's not quite right, but it will be right always in Science 9. 9, blah, 10, blah, 11, sure. 12, sure. There's some concepts. What you can practice is the naming and the crisscross. So certainly 14 is good. Certainly 15 is good. I think 15, none of these are multivalent, so it's just going to be the IDE rule. They're all ionic because I see metal, 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 metal. So no Roman numerals. 16, going from a word to a formula, sure. And I also see metal, 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 metal. These are all ionic, and none of those are multivalent. Now we're getting into the multivalent ones. These are all ionic, so that's worth practicing. Going backwards, multivalent, that's worth practicing. Polyatomic, and putting everything together. Some polyatomic, some multivalent, the whole schmear. If you want to, you can practice those. Okay? Good luck on your test. Oh, and Merry Christmas.